Hello everybody, and welcome on back to the science behind that. I hope you guys have yourselves a nice steamy hot cup of coffee right next to you. I don't today, unfortunately. I just have my bottle of water here, but make sure you get that coffee. I did have some coffee today, so don't you worry about that. So I know I've been gone for a while, so what happened? Well, I graduated. That's the biggest thing. So yay, I'm no longer a college student. So I'm done with that, and I moved, as you can see. Little different background behind me. I would use my green screen, but unfortunately, my green screen is too small to work, so I'm not gonna use that. But here we are. We got the bows and the bows and the microscope right behind us, and of course the flag of the motherland. So today we're going to be talking about the science behind cryotherapy. Now this is going to be a kind of like sneak preview to this. So all of you guys on YouTube who are watching this right now, the podcast version of this episode will be up on Friday. So I guess, yay, this is kind of cool. You guys get the sneak peek. So today we're going to be talking about the science behind cryotherapy. What is it? How does it work? And does it really do everything that people say it does? So I personally am a really big fan of cryotherapy. I take a cold ice bath every night, especially on nights when I train. I do a cold ice bath every night, and I don't know, I find that afterwards I feel refreshed. I feel healthy, ready to go. So I really like cryotherapy. Now, a while ago, I looked this up because it was for a research project that I was doing for one of my classes. It was the efficacy of cryotherapy for muscular repair. And I was really curious if it, helps with muscular repair, or if it increases the rate at which muscles repair themselves. So I looked this up. I did a lot of research for this project, and I found out that cryotherapy doesn't necessarily speed up the rate of muscular repair. Instead, what it does is it decreases inflammation acutely, so that muscles can repair without the interference from the immune system. And if we are to understand how this process actually works, we have to understand what is actually happening when you're working out or when you're tearing muscles. So I've talked about this a little bit before, a little bit in the past, which is that when you're working out, what happens is there's two different types of working out. There's a workout that gives you a pump where the muscles just, become filled with blood. And then there's a workout that is for, I think people often call it like working till failure. And that is where you're actually tearing the muscle cells themselves. So I have a muscle cell here. So here's my little skeletal muscle. And when you're working out for a pump, you're so you're having your expanded muscle like this. You're contracting and relaxing, contracting and relaxing, right? Back and forth, back and forth. And this causes a lot of blood to flow into the area, and as a result, your muscle gets really big, really pumped. So if it's your bicep, your bicep gets really pumped, your pecs get really pumped, whatever, because they get filled up with blood, because the blood is providing the nutrients that the muscle needs to function. So that's called a pump or a feeder workout, as I've heard other people call it, where you're feeding your muscles, you're getting a pump. The other type is a go to failure workout where you're actually tearing the myofibrils or tearing the myocytes themselves. And what happens is when you rip a myocyte in half, that releases cytokines. Well, more specifically, what happens is it releases these proteins, which are then eaten by macrophages in the surrounding area, and that results in cytokine production. And when that happens, you have an immune response. But part of the importance of these cytokines, along with resulting in the immune response, is that the proteins that are ingested by the macrophages that are released from the torn muscles, those proteins then induce the formation of keloid tissue. So you have your fibroblasts coming along, and what they do is they fuse the myocytes together, the torn myocytes together. They fuse them together, and they do that using collagen and actin and a little bit of myosin, but mainly collagen. They fuse it together, forming keloid tissue, and that increases the total strength capacity of the muscles themselves. So that's how you can get, you can have a dude who looks really yoked as hell, but maybe he's not very strong. And he might not be very strong because getting the pump does not necessarily correlate to an increase in strength. The strength comes when you're fusing myocytes together with that collagen. That's where the strength comes. Same with bone, right? So bone is a matrix of a compound called hydroxyapatite. And it's a matrix of hydroxyapatite and collagen. The collagen provides the flexibility, if you will, whereas the bone provides the strength. So if you don't have enough collagen in your bone, you have really fragile bones, really brittle bones that are very, very prone to breaking. This condition is called osteogenesis imperfecta, and conversely, if you don't have enough hydroxyapatite, your bones are really flexible. I'm not sure if that's a thing, but that would be the opposite of osteogenesis imperfecta. I don't know why I just blanked on the term there, but so that's what's going on when you're tearing muscles, or when you're working out really hard, when you're going to failure. You're tearing these muscles, which results in these proteins to be secreted and an immune response. Now, the issue here is that the proteins that are released when a muscle fiber is torn are really important for bringing fibroblasts in, but the side effect of it, where they excite the immune system, that's a very negative thing, and that has been shown to slow the rate of muscular repair. So how does this relate into cryotherapy, you may be asking? Well, that's a good question. What has been demonstrated is that cryotherapy reduces the immune response to an area of muscle tears. So there's an experiment in particular that was done on zebrafish. Now, you may be saying, why zebrafish? Because for whatever weird reason, zebrafish muscle is very, very similar physiologically to human muscle. Very odd, I know, but it makes them a model organism for musculoskeletal studies like this. So it was determined that what cryotherapy does is it significantly reduces the perfusion of macrophages, cytokines, and other immune cells to damaged muscle tissue sites. So what does that mean? What that means is because there's a reduction in perfusion with cytokines, macrophages, and other immune cells, the rate of muscular repair could theoretically increase. Now, the rate of muscular repair was not analyzed in this particular study, but in other studies we do know that when you have less immune cell perfusion to an area of muscular tear, the rate of muscular repair increases. So in the short term, then, it was determined, overall, in the short term, it was determined that cryotherapy reduces inflammation in torn muscles. And that's a good thing because that means that the muscles can repair more efficiently without having to worry about the immune system getting in there and messing things up. Now, what about in the long term? What are the long-term benefits of cryotherapy? In a beautiful twist of irony, if you will, in the long term, so chronic use of cryotherapy actually strengthens the immune response. So in the acute time frame, right, the short term, cryotherapy decreases the immune response, inflammation with at sites of muscular injury. But over the long term, cryotherapy increases the immune response. And what do I mean by that? It increases the efficiency of the immune response of the immune system to recognize pathogenic threats, and it decreases the amount of autoimmune activation. Now, what is autoimmune activation? Autoimmune activation is when the immune system sees self, right? It sees something that's part of our normal healthy cells, and for whatever reason it thinks it's a pathogenic threat, and so it attacks it. That's autoimmune activation. And what we've determined is that with cryotherapy, after a long period of time of doing cryotherapy, here's a plane, sorry. After a long period of time of doing cryotherapy, the prevalence of autoimmune activation is decreased, and the efficiency of the immune system at recognizing pathogenic threats and taking them out is increased. So, ladies and gentlemen, so what does that mean overall? It means that cryotherapy potentially serves to be a new maybe treatment for autoimmune disorders, although I don't want to make any assertions immediately, but it does serve as an exciting new area of research. It also means that, ladies and gentlemen, after your workouts, you should make sure that you're doing cryotherapy. Everyone should be doing cryotherapy, in my opinion. It's really helped me out a lot. I love doing cryotherapy. I just feel so much more energized afterwards. And we have the evidence to suggest that it may be strengthening your immune system. So especially in a time of the big coronavirus pandemic, of the SARS-CoV-2 pandemic, maybe it wouldn't be so bad if we all did everything we could to strengthen our immune systems. That is all I have for you guys today. I will be back to you guys on Monday with another exciting episode of the science behind that. Until then, remember, ladies and gentlemen, stand up and question everything.